If you are designing enterprise security today, you are designing for cloud. Whether your organization operates fully in the cloud or in a hybrid environment, cloud platforms are no longer experimental. They are foundational. Your enterprise likely runs workloads across Microsoft Azure, Amazon Web Services, possibly Google Cloud, alongside legacy data centers and SaaS ecosystems. This multi-cloud and hybrid reality changes the nature of architecture. Infrastructure is no longer static. Networks are software-defined. Identities are federated. Resources are provisioned automatically. Developers can deploy globally in minutes. If you do not design cloud security architecturally, complexity expands faster than governance can handle. Cloud security architecture is not about securing virtual machines. It is about designing secure platforms at scale. The first principle you must master in cloud architecture is the shared responsibility model. Cloud providers secure the infrastructure of the cloud. You secure what you run in the cloud. In practical terms, the cloud provider is responsible for physical data centers, hardware, hypervisor security, core platform resilience. You are responsible for identity configuration, access management, data protection, network design, logging and monitoring, application security, compliance configuration. The misconception many leaders have is assuming that moving to cloud automatically increases security. Cloud providers offer strong baseline infrastructure security, but misconfigurations, excessive permissions, exposed storage, and weak identity governance remain your responsibility. As an architect, you must design controls, assuming that misconfiguration is the primary threat vector. Cloud security failures are rarely due to broken hardware. They are due to architectural gaps. Cloud platforms provide powerful native security capabilities. The question is not whether they exist. The question is whether you architect around them intentionally. Cloud native controls include identity and access management frameworks, role-based access controls, native logging services, security posture management, encryption services, key management systems, threat detection integrations. Instead of replicating on-premises security models in the cloud, you must embrace cloud-native design. For example, rather than deploying traditional network firewalls everywhere, you can design identity-centric access policies combined with platform-native network controls. Rather than manually managing encryption keys, you can use cloud key management services integrated into applications. Cloud-native security is scalable because it is integrated into the control plane. If you ignore cloud-native capabilities and attempt to recreate legacy architectures, you increase complexity and cost. Architectural maturity means using native capabilities strategically while maintaining enterprise governance consistency. One of the most critical aspects of cloud security architecture is the landing zone. A landing zone is not just a subscription or account. It is a structured, pre-secured environment designed to host workloads securely. If you design landing zones correctly, you achieve standardized identity integration, predefined network segmentation, centralized logging, policy enforcement, secure connectivity, role separation. If you design them poorly, every new workload introduces inconsistency. Landing zone security typically includes centralized identity federation, management group or account hierarchy structure, baseline security policies, network topology standards, log forwarding to centralized SIEM, role-based access model definition. Think of landing zones as architectural guardrails. Developers and business units can innovate freely within them, but the foundational controls are already in place. If you do not secure the foundation, scaling cloud becomes chaotic. In hybrid and multi-cloud environments, identity becomes the unifying control plane. Your architecture must support single sign-on across environments, centralized authentication, conditional access enforcement, role-based authorization, Privileged identity governance. Identity federation allows users to authenticate once and access multiple cloud platforms securely. For example, integrating enterprise identity providers with both Microsoft Azure and Amazon Web Services enables centralized governance. Without federation, access sprawl increases, privileged accounts multiply, audit complexity expands, risk visibility decreases. Federated identity ensures that zero trust principles extend across cloud boundaries. It also simplifies lifecycle management. When a user leaves the organization, disabling access centrally revokes access everywhere. That is architectural elegance. Hybrid environments introduce additional complexity. You must ensure secure connectivity between on-premises and cloud, consistent logging across environments, unified identity policies, standardized encryption practices, segmentation between IT and OT where required. Many organizations underestimate hybrid risk. For example, if cloud workloads are secure but on-premises identity systems are weak, attackers may exploit the weakest link. Enterprise cloud security architecture must view hybrid environments holistically. You cannot secure cloud in isolation. You cannot secure on-prem in isolation. You must design trust boundaries, data flows, and access controls consistently. Cloud introduces agility. Without governance, agility becomes risk. Cloud governance strategy must define account or subscription structure, role and access standards, policy enforcement mechanisms, cost management alignment, compliance mapping, logging retention standards, data classification enforcement. Governance is not about restricting innovation. It is about creating safe boundaries within which innovation can thrive. For example, policy as code can enforce encryption requirements automatically. Access policies can prevent privilege escalation. Centralized logging standards ensure audit readiness. If governance is manual, it will fail at scale. If governance is automated and embedded architecturally, it becomes sustainable. As an architect, you must design governance mechanisms that are repeatable and measurable. Cloud adoption is usually driven by business goals: faster innovation, reduced infrastructure cost, scalability, global reach, digital transformation. Your cloud security architecture must enable these goals, not obstruct them. For example, if the business demands faster application deployment, your architecture must integrate DevSecOps controls into pipelines rather than requiring manual reviews. If cost optimization is a priority, your architecture must balance logging retention with storage efficiency while maintaining compliance. Security cannot be a roadblock. It must be a design principle. When cloud architecture is aligned to strategy, security enhances agility instead of slowing it. Threat actors increasingly target cloud misconfigurations. Common risks include publicly exposed storage, over-permissioned identities, misconfigured APIs, inadequate logging, unrestricted service-to-service access. Your architecture must assume that configuration errors will occur. Therefore, you must design continuous monitoring, automated policy enforcement, least privilege models, segmented network architecture, centralized logging. Risk-based design means anticipating failure and containing it. Cloud security is not about perfection. It is about resilience and rapid detection. Executives are concerned with regulatory exposure, operational resilience, cost efficiency, brand reputation, scalability. When you present cloud security architecture, frame it in terms of reduced risk of misconfiguration breaches, improved visibility across multi-cloud, standardized governance, faster secure deployments, enhanced compliance posture. Executives do not need deep technical diagrams. They need assurance that growth does not increase unmanaged risk. Your role is to translate architecture into confidence. Ask yourself, is your cloud environment governed by design or by exception? Are landing zones standardized? Is identity centralized and federated? Are logging and detection unified across hybrid systems? Is governance automated or manual? Cloud security architecture determines whether your enterprise scales securely or scales risk. It requires structured thinking, long-term roadmap planning, and cross-domain alignment. If you design it well, cloud becomes an accelerator. If you design it poorly, cloud becomes a liability. If this lecture helped you understand how to design cloud security architecture strategically, make sure you subscribe to this series. In the next sessions, you will dive deeper into identity-centric design, DevSecOps integration, and enterprise security operations, all building on this cloud foundation. Like this video if you found it valuable. Comment below and tell me, is your cloud security approach reactive or architected? Your journey toward mastering enterprise security architecture continues in the next lecture.